Welcome back. Today we are doing day 2 of our properties, and we're going to be talking specifically about the distributive property, which is brand new to you, so you've never seen it before, and it's exciting. Our learning target is to apply the following properties, which is the distributive property. We've already covered all the others, so we're not going to go over all that. Okay, so if you've ever heard of Walmart, I'm sure you have. I'm sure you've all been there. I know that some of you have because you brought in things and talked about going to Walmart. Well, Walmart is a huge organization, and they have these places called distribution centers, which is what's pictured up here on the left. That is where it's like a huge warehouse, and that distribution center is the one that takes all the merchandise and sends it to all these Walmart stores all over the country. They use these trucks that are here and they drive it. They also can put it on trains. They can put it on airplanes, depending on how fast they need it shipped. But this is the distribution center where everything starts. And so we're going to kind of tie into that with the distributed property or distributive property. So I just wanted to kind of get your mind wrapped around what is a distribution, what's it mean to distribute. It means that we're going to share things with others. So I know you guys like video games, so let's think of it in terms of Angry Birds. So in Angry Birds, you've got this angry bird that's over here, and he's got to attack these ugly little pigs over here that are laughing and teasing him and being mean. So there are some of these birds that when you hit them, they split and into these tiny little birds, so it's kind of splitting them and sharing them. And that's kind of along the same lines of what we're going to be doing today. So think of the distributive property as this angry bird guy outside the parentheses is wanting to attack these pigs that are inside the parentheses. And he has to get this guy with the hat and he has to get this other guy without the hat, but he's got to knock them both out. So basically we're sharing that blue bird, the angry bird, with both of the pigs. So that's all we're doing with the distributive property. If you look at the example we give you in terms of math, we use this when we have variables, but we're trying to simplify a expression to make it easier so we know it's getting as small as we possibly can. First, before we get started, if you could take your pencil and change that multiplication sign between the m and the 12 to an addition sign. It's supposed to be addition, not multiplication. All right, so this 5 is like the blue angry bird, and we have to share him with everything inside the brackets or inside the parentheses, inside the grouping. So we are going to use multiplication to share the 5 with the m, and then use multiplication again to share the 5 with the 12. And how we expand that or rewrite it is 5 with parentheses and m's inside the parentheses. That means to multiply. And then again, we multiply the 5 times the 12, and we rewrite it as 5 parentheses 12, which means to multiply 5 times 12. Then if we do that, remember we don't use those x's anymore, use dots, we end up with 5 times m and 5 times 12. And that can further be simplified. We can just write 5 and m together using a coefficient variable, and then we can do 5 times 12, which is 60. Now, once I get there, I cannot combine anymore because this right here means that I'm multiplying by 5 times m, and then I'm adding 60. But if we think of our order of operations, before I can add, I have to multiply. But I cannot multiply this because I don't know what m is. So that's why when we get to this place where we have 5m plus 60, we can't go anymore. It's done. That's as low as we can go. And that's called simplifying the expression. So let's look at your notes. In the middle of your notes, under the Angry Birds, you see distributive property and then the definition of what the property means. So what the property basically is saying, it's a number on the outside of the parentheses is distributed, just like the Walmart distribution center. It's distributed or multiplied. That's another way to think of it. That's really what we're meaning, is multiplied to every term inside the parentheses. So if you look at our examples here, and we did it just with letters, but I'll show you some examples with numbers. A times B is written here, and then A times a positive C, so it's a positive AC. And the distributive property, I like to think of, it starts with a D, and that reminds me that it's different because it's the only property that actually works with subtraction, and it's also the only property that has two operations going on. We have multiplication here, and we also have addition, or we have multiplication and subtraction. So it's different for two reasons, because it has two operations, so it can't be classified as multiplicative or additive because it has both, and it's also the only one that you can use with subtraction. So if you see anything where there's subtraction, you know it has to be the distributive property. So let's look at another example. Say I had 3, and then I had a negative 2 plus C. I have to take that 3, and I told him one of my other classes said it's like that annoying boy or girl that goes around kissing everybody at a party. So the 3 has to kiss that negative 2 or multiply by that negative 2 and then kiss that C. So we rewrite it as 3 times negative 2 plus 3 times that C, or just 3C. I don't have to use the parentheses. I can, but I don't have to. And I could simplify this further because 3 times a negative 2, let's see if I bring out my integer Bob here. I have a positive times a negative. What's left is a negative. 3 times 2 is 6. So then my answer would be negative 6 plus 3C. So that's how you do it with numbers. Let's do one more, just so you get an idea of something else that you might see. What if I had a negative on the outside, and I said, what is negative 2 times A minus 4? So now let's look and see. If we share, we have to have negative 2 is going to kiss A, and if it's a coefficient or we're multiplying by a letter, we can just simply write negative 2A. We don't have to use parentheses. You can, but it's not wrong. Then now we're going to have a negative 2 times a negative 4. So what is negative times a negative? Well, if I look at integer Bob, a negative times a negative leaves that positive. So it's going to change to positive, and a 2 times a 4 is an 8. So that's how you're going to do that moving forward. And I just want you to be able to see that you're multiplying each term, and we're going to do some more practice. So, but that's just two really quick examples. Okay, look at the bottom of your page. We've got lots more practice. Again, we've got that annoying 5 at the party that's going around kissing everybody. So 5 is going to kiss 4. And that means 5 is being multiplied by 4. Now 5 is being kissed by a negative 8. So what is a positive times a negative is a negative. And now I'm going to write 5 times 8. Okay, and then I can simplify this further. So 5 times 4 is 20. 8 times, or negative 5 times 8 would be a negative 40. 20 minus 40 gives me a negative 20. And I want to show you something that if I were to do this problem, you don't have to write this, don't write this. If I were to use order of operations, 4 times a negative 8 is negative 4. If I multiply 5 times a negative 4, I get a negative 20. I have negative 20 here, and I also have negative 20 here. So it doesn't matter how you solve it, whether you use the distributive property or you don't. However, that's with it being straight numbers. You will not typically use the distributive property if it's straight numbers. Only time you're going to use distributive property is if you're going to have letters or variables inside the parentheses. Okay, let's look at our next example. We've got that annoying 3 here going to the party and kissing the x, and now is kissing the y. So now 3 is being multiplied times x, and then we're adding the 3 being multiplied by the y. And I can rewrite that as 3x plus 3y because there's nothing to truly multiply. It's just 3 being smushed with x and 3 being smushed with y. So 3 is the coefficient, x and y are the variables. Let's look at some more examples. Remember our Angry Birds. Now we've got M, whether it's kissing at a party or Angry Birds, the M is going to attack the 4. Oops. Should be an M, not a 4. So M's being multiplied by 4. Now M's going to be multiplied by N, and it's positive, so we're going to put the positive in the middle. And I can rewrite this. Typically, when you see your coefficients, the number comes first. So it would be 4M plus Mn. And what allows us to switch that around, what property? The one that allows us to change the order of multiplication is the commutative property. Okay, let's do number 4. Let's look at number 4 because number 4 looks different. What's different about number 4? The 2 is being multiplied, but it's in the back. So again, we can use the commutative property. You don't have to write this, but the commutative property of multiplication means that I can take that 2 and move it to the front. So now I have 2 times the quantity 5 minus 3, because all I'm doing is taking my 2 factors and switching them around. So now it looks like something I've seen before, and now I can do my distributive property. Take the 2 and share it with the 5, and then take the 2 and share it with that negative 3. So 2 times 5, and then we have 2 times a negative 3, which would be a negative answer. So I'm going to leave that negative in the middle. So then I can simplify more. 2 times 5 is 10, and negative 2 times 3 is a negative 6. What is 10 minus 6 is 4. So you can do it, go simplify that far, but you're not going to have that. I'm going to let you guys try 5. I'm going to let you guys try 6. We are going to do number 7 together. So jump down to number 7. I'm going to have you do 5 and 6 for your Edmodo. So if you look at number 7, this one's a little different because I have a negative. I'm multiplying by this negative here. So if the negative 2 is multiplied times W, that's going to give me a negative 2W, correct? What happens if the negative 2 is multiplied times a negative V? A negative times a negative would give me a positive answer. So I'm going to take those 2 negatives, make it a positive. Now I just have 2 times V, which is 2V. Or if you forget that integer rule and you're just writing this out, you can write minus a negative 2 and V. And then if you look here, you've got those double signs. You're going to change them into an addition problem. So I'm going to let you guys go ahead and do 5, 6, and 8 for your Edmodo. And we're going to look at a different type that you may not have seen. This is doing your distributive property in reverse, so it's a little bit more challenging. So this is our distributive property, what we started with before, and this is its product or its answer. So you're going to look at what is the factor that's being shared. So if you look at, I've got 2x, 2 times x, and a 2 times a 5. Well, what's the thing that they have in common? It's that 2. So what's going to be pulled out to go on the outside? Who's kissing everybody? 2. 2 is being kissed or kissing everybody. Now if you do that and you take that 2 away, what's left? You have the 5 here, that's already written, but what's left over here is simply that x. All right, I'm going to let you guys try number 2 for Edmodo. And now let's look at some different. These are more challenging problems. These are more of what you're going to see when you get to your SOL moving forward. Same principle, that everything is still the same. We're still going to take this 6 that's out front here and share it. He's going to kiss the 1, and it's going to kiss this 5 and this M. So, but because this is different, it has a 5 times an M, and we're going to talk about that. That means that 5 is being multiplied times m, correct? So if we take this and we show our work, we're multiplying times 1, then we're subtracting, that's from the middle, and I'm going to multiply by a 6, and then we have a 5, and we're multiplying by m. With multiplication, we know 6 times 1 is 6. That's the identity property. We know that. But with multiplication, can't I take these two in the front, 6 times 5, and multiply them? If I do, I get 30, and then that m is still being multiplied, so it has to tag along for the ride. And again, this has to be multiplied before I can subtract, so that's as low as I can go because I don't know what m is. And I'm not going to know what m is until I give me, m is equal to this, and I don't give that. Okay, so you guys, let's try number 4 together, and then I'll do 4, 5, and 6, and let you guys try the rest of them on your own. So if you look at number 4, I'm taking this -2, and I'm going to take that -2, and I'm going to share it, or it's going to kick 1, so I have -2, and it's kicking or kissing 1, whatever you want to think. Now I've got the -2, and it's going to kiss or kick 5V. That 5 and that V are going to tag along together. Even though in the first example I split them apart, you need to understand that that just means multiplication, so I can combine the 5 and the 2 by multiplying, and the V is just going to tag along. So if I look at this, -2 times 1, identity property, whatever I multiply by 1 stays the same, so that's just -2. Then I have a negative and a negative here in the middle, double signs, so I know that's going to turn, whoops, my negative is going to turn to a positive, and now I have to multiply 2 times 5. 2 times 5 is 10, and that V is still being multiplied, so it's going to hang around. That's all we're doing. We're sharing the number on the outside with everything inside. Even if there's a variable tagged to that number, you can multiply the numbers and keep the answer the same, or just have the variable tag along. Okay, so let's look at number 3. We have this this 5 out here, number 5. We have the 3 out here. He's hanging out. He's going to go visit the 4. So we have 3 times 4. Now the 3 is going to go visit the 3R. And we're going to multiply 3 times 4 is 12, plus 3 times 3 is 9. Do not write 6. That's addition. We're multiplying. And the R is going to tag along. Okay. Let's look at the next one. We'll look at number 6. We have again a 3. The 3 is going to kiss the 6R. 3, 6R. Now the 3 is going to kiss this -8. Okay, now 3 times 6 is 18. And the R tags along. And I have 3 times a -8. Integer rule says positive times a negative is a negative. 3 times 8 is 24. So there's my answers for those. All right, you're going to try 7, 8, 9, and 10. Be careful with numbers 9 and 10, because numbers 9 and 10, you're going to have negatives being multiplied by negatives, and so on and so forth. I changed my mind. I'm going to do number 9 with you because I want you to understand what's being done here. If you look at number 9, there's nothing written up front. There's just a negative sign. There is a secret number here. It's understood to be a 1. So if we rewrite this as -1 times 2c, -2c minus 6. Now I'm going to take that -1, I'm going to multiply it times -2c. Now I'm going to take that a negative times a negative. I'm going to -1 here and a -6. A negative times a negative is a positive. 1 times 2 is 2. C tags along. So those negatives, remember our integer guy? Negative times a negative is a positive. And we have a -1 times a -6. Again, that's going to change to a positive. 1 times 6 is the identity property. It stays 6. So that's how you're going to do that one. I will let you guys do number 10. Be careful. Watch your signs because you're going to have some positives and negatives in there. You're going to do 7 and 8 as well for your Edmodo quiz. And when you come back on, I will see you guys again on Monday. We will have a properties quiz at the end of class. We'll review, work on our foldables, and do a little bit of our project. But I want you guys looking over these so that you're ready when we have our quiz on Monday.